This is TechSNAP, episode 376. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on July 26th, 2018. It's brought to you by our three great sponsors, iXSystems, Ting, and DigitalOcean. I'll tell you more about them as the show goes on. My name is Chris, and joining me every single week is my co-host, the admin, the engineer, and the presenter. It's Mr. Payne, Mr. Wes Payne. Hello, Wes.
Why, hello there, Chris.
Hey there, Wes. Why don't we start out with a story that piqued my interest as a frequent road tripper? It appears it's much easier to confuse navigation systems than we would have liked. Researchers from a number of renowned institutions, including Virginia Tech, the University of Electronic Science and Technology of China, and Microsoft Research, have concluded that it is possible to spoof GPS signals and send people in the wrong direction.
The worst part? This can all be done with less than $250 worth of equipment. The researchers tested these findings in a range of attacks launched in China at night. Now, that's a little bit key because you're relying on humans to be reliant on software. And during the day, if you're in an area you know, then maybe GPS doesn't matter so much. But you're driving into a new town at night, you can't see what's happening, you're pretty vulnerable. They attacked a Ford Escape in particular and used two different models of mobile phones running navigation software by Google. What's new about this attack is basically that they've done a better job once they've reached GPS, once they've spoofed the GPS signals you're getting, the directions they're providing you fit up with the real layout of the physical map. And that's what's different, because a lot of times in the past, sure, you could spoof GPS, but if it was obviously fake, if it was trying to tell you to turn somewhere that just wasn't a road, well, that's not going to work, right? You'll be like, okay, well, no, I'm not going to turn into the lake. I'm not that stupid. But if you don't know where you're going, you don't know how far it is, you don't really have any sort of human heuristic senses to save you, and you're given bad directions, now that is a worthwhile attack.
Yeah, and I honestly do know folks that would turn right into a wall if the GPS system told them to. We know them. They may or may not work with us here at the network, and they may or may not just live blindly by their nav when they're driving in new areas. And it may or may not be someone that sometimes may or may not go by the name of Noah. I don't know.
Yeah, exactly. They were able to test this with various traffic simulators across China and the United States, and it can work in real time using a portable GPS spoofing tool that basically it retails for around $223. It can be attached to any vehicle or put on a car that tracks another one from a distance of up to 50 meters. Hey, that's pretty good as long as you can follow someone through traffic. 38 out of the 40 participants, now that's not a giant sample size here, but it's something, followed the navigation to all the wrong destinations. If the attacker aims to endanger a victim or, just confuse them, the new algorithm can successfully craft special attack routes that contain wrong ways for about 99.8% of the trips. Now, I don't know if this is immediately useful, and it's definitely a more targeted attack because you need some sort of endgame. Sure, you could start with some low-level, just trouble causing, basically, of spoofing GPS and allowing people to be redirected, confused, not get where they're going, cause all kinds of traffic congestion. I think targeted attacks are really where this is going to be a big deal once it becomes more plausible, once you've done a better job. So GPS is pretty spoofable just in general because it's a very passive sort of protocol, right? Your phone's reaching out, you're receiving these global positioning signals from the satellites, and then you can sort of find out where you are on the globe using some fancy math.
And the signals themselves are inherently weak because of how far away they're being transmitted from, so it's pretty easy to interfere with them.
Yes, exactly. And I think where this comes in is they've just done a better job of integrating with the ways that GPS are actually used by end users, right? So you've got your Android phone, you're using Google Maps, you've slapped that up on your phone holder, on your dashboard. Hopefully, you're not just holding it in your hand, and then you're just blindly following it. So if it looks realistic, if it's using realistic routes, if they can put in a ghost location that looks like it's actually leading you to the Costco that you wanted to go to, but is actually sending you to a bad part of town where you're going to get mugged or attacked or kidnapped, that's real trouble.
Yeah, and the European Global Navigation Satellite Systems Agency tallied roughly 50,000 incidents of deliberate jamming in just the last 2 years. They noted that most of those were truckers and ride-hailing drivers trying to hide their locations from employers during breaks. So most of it are, innocuous uses in the big picture, but some of it is more weaponized and could be used to do damage or even steal information or people or things.
Yeah, I mean, if you're hauling precious cargo, maybe consider paper maps.
Well, surprise, surprise, we have flaws in Bluetooth, and these ones might be around for a little while, but if you're lucky enough to have a device that is still supported and getting updates, then you may see some fixes soon, because there's a bug in there that allows an attacker to do a man-in-the-middle attack and even grab your data.
Last Monday, we saw a new vulnerability advisory from CERT, which laid out the details. Basically, it comes down to this. Firmware or operating system drivers skip a vital check during the diffie-hellman key exchange that allows Bluetooth devices to connect while they're pairing. The impact? A nearby eavesdropper could intercept, decrypt, or forge or inject device messages that are carried over Bluetooth low energy, Bluetooth basic rate, or Bluetooth enhanced data rate wireless connections.
So in other words, you could potentially snoop on supposedly encrypted communications between two Bluetooth devices. You could steal their information that's transmitting over the air. You could inject malicious commands. To pull this off, you just have to be within radio range and transmitting while the gadgets were doing their initial pairing.
This particular weakness crept into pairing implementations that use diffie-hellman key exchange in particular. Now, during pairing, the two devices are meant to create a shared secret key based on an exchange of their public keys. And I mean, this is pretty common, right? You use public key encryption to establish a shared symmetric key that you then use for some amount of time, a whole session, maybe you rotate it during the session. That can all depend on the particular implementation. But the idea is you start with public key, and then you get a symmetric key. Part of that exchange is that you both agree on certain elliptic curve parameters that both devices will use. Now, some implementations don't validate all of those parameters, and that lets an attacker inject an invalid public key, and then they can determine the session key with a high probability. It's not 100%, but such an attacker could then passively intercept and decrypt all device messages. Or, because it's trusted, they could forge or inject malicious messages into your communication. So you think you're just transferring contacts, and no, you've got the wrong number, or, now your phone is hacked due to other vulnerabilities that may be present on your device because what you thought was a trusted connection wasn't.
So this really seems to impact any device that uses simple, secure pairing and Bluetooth LE connections. So far, we have acknowledgments from Apple, Broadcom, Intel, and Qualcomm. And Microsoft has said our devices are not affected.
Yeah, really, in this case, the only thing you can do is hope that you have a supported device. This is maybe yet another reason to, unfortunately, keep up with device timelines just because it is important to have security updates that are going to reach your device. And if you do have such a device, stay tuned for security updates and apply them when they're available.
It would be fascinating if somebody compiled a list of all of these types of updates over the years that require having an Android device that gets active updates, because these fixes need both software and firmware updates for these devices. So that's not going to be a huge amount of Android devices. It'll be some, but it would be fascinating to have like a complete list of these types of updates that have required having something that gets frequent patches. Because I got to imagine if you have a device now that hasn't received any updates for a couple of years, that's a pretty scary list for your device.
It's also just a good reason to be careful with, just like in real life, be careful who you pair with.
Or another way to put it, don't pair in public, kids.
Exactly.
Earlier this year, Google removed the ability to use domain fronting through Google's App Engine. At first glance, it didn't really seem like much to me, but Wes definitely noticed this took place, and it's had the anti-censorship and privacy forums up in arms for the last few months. There's been an entire industry built around domain fronting, so Mr. Payne's going to break it down for us and start with explaining what domain fronting is.
Well, fronting is kind of a key part of the name. Domain fronting is really just when your application or network service uses someone else's domain name. So, I'm interested in going to jupiterbroadcasting.com to go check out some great new podcasts. But unfortunately, the region I live in doesn't think that's a good idea and will block those connections. But they're totally down with Bing. They just love Bing for some reason. So if I was able to go use a trusted domain name, something like Bing, go to a Bing service, but then in actuality, get Jupiter Broadcasting content, that would allow me to skip through that block. And that's the basic idea of domain fronting. So Google made some big news. Amazon made some big news. There's really been a lot of developments around. I think it really all started with Russia blocking a bunch of IPs across some various cloud providers trying to prevent access to Telegram. From there, we saw news of Google stopping domain fronting from working on their network, Amazon following suit, and there's been a lot of rumors about the various other cloud providers. But I think Google makes a pretty good case study. So let's start there. In the case of Google, their app engine assigns domain names that end with .appspot.com, which is a Google-owned domain. For example, you might have snowflake-registry.appspot.com or inkpad.appspot.com. It doesn't really matter, right? When you host something, you get this .appspot.com. Now, due to particular network configurations within Google, these application domains used to be accessible through https www.google.com. Now, it wouldn't work, right? We've all typed that into our browser. You go to Google, you get the Google homepage, you do some searches, you find some cat gifs, and it all works just great. But if you specifically manually construct specific HTTP headers, you can take advantage of the domain fronting capabilities. And that's where this first starts. It is not something that just happens for arbitrary clients. It's not something that you're going to do unless you know that you do it. And that's why it has anti-censorship use cases, because specific clients, things like e.g. Signal, do make specific requests that try to obfuscate the content that they're actually contacting. So that if Iran or Syria starts blocking that service, well, they probably won't block Google, right? That's just going to have too many ramifications. There's so many things hosted by Google, even government things sometimes, right? So you just can't have such a wide network block. But it's easy to block a particular domain name. It's easy to block a particular small subset of IP ranges. Let's break this down in a little more detail. Now, Chris, you're familiar with how like a normal HTTPS connection works, right? So if I'm out there as a regular user on the internet and I want to go get some content from the SSL version of jupiterbroadcasting.com, how does that work?
I suppose if you really start at the beginning, it would be a DNS request to resolve jupiterbroadcasting.com, and then from there you would make the HTTPS connection to the web server.
Yeah, exactly. If we go a little bit deeper, there's like a couple more parts. So first, right, you make the DNS request, you get the IP that you're actually going to talk to, and then you can set up a layer 3 connection to that IP. Once you've got that TCP connection going, you can do an SSL negotiation. So you start doing TLS, you start saying, you might have something here like SNI where you have multiple SSL sites hosted on one thing. So you say like, hey, I'm trying to connect to this website. Can you send me the certificate that you have for that? And then you use the normal, cryptographic methods to validate that, yes, that certificate was signed by a certificate authority that I trust for the website that I'm trying to go to. Now, the part we kind of forget in our, HTTPS everywhere world is that after that happens, there's still regular HTTP that happens under SSL. And so you send a normal HTTP 1.1 request with a host header saying, hey, I want to get, / for your website, and I'm trying to get the website for a specific host, in this case, jupiterbroadcasting.com. Where that's a little bit different when you're doing domain fronting is all that first stuff is totally the same. So let's say we were trying to do this over Google, right? So we would set things up. We would be using a trusted Google domain name that we would think third parties would not dare to block. We would connect to, DNS would look up and give us the IP of that usually something like some sort of, Google Edge CDN that does a bunch of caching for their sites. They would also have SSL termination set up. Once that all happened, instead of requesting that specific Google domain, we would instead request jupiterbroadcasting.com. And if we'd configured it correctly so that was hosted on Google's infrastructure, Google's proxy or cache at that edge would know how to serve that content, right? It doesn't care about DNS. It doesn't care about SSL termination. That's all been offloaded onto some load balancer or firewall way up in the stack. So at this point, it's just something serving HTTP, and it all gets encapsulated, as the request returns to the user. And if it knows how to serve that request, and that part is key, right? So like, it can't just be any old website. You need to be either hosted on that CDN or hosted on backend services on the same IP or on the same network that it knows how to access. But if it does, it can go serve you that content. And it looks like you've hit a legitimate Google website, but you've gotten content from whatever arbitrary backend that you've managed to set up.
That actually makes a lot of sense, so thank you for the explanation. Now to what's recently happened. On April 13th, some Tor developers noticed that domain fronting at Google stopped working, and Google responded stating that it was part of a long-planned change. And interesting, around that same time, Amazon disabled domain fronting on Amazon CloudFront as well, which I'm not quite clear why they would want to turn this off, and if something has changed recently.
Yeah, I think that's where it gets a little bit difficult to negotiate, because there are a lot of legitimate anti-censorship use cases here, right? Especially in parts of the world that, don't have a lot of respect for free flow of information. And we're very privileged in that regard. Not everyone is. And I think there's a lot of legitimate interest in trying to find ways using the open internet to sort of, get people the content they want. Now, that doesn't want to encourage, we don't want to encourage illegal or unethical behavior, but a lot of times there are very legitimate use cases to just have information, and censorship on some of the more sketchy areas of the internet it's just not a good thing. But the key point is that domain fronting it's really a hack, or maybe a better word is side effect. It just happens to be a thing that works because we rely so much on these big centralized cloud providers that you just can't block all of, and B, just some nuances in the separation of concerns and the layers in our application and technology stacks. Like it wasn't necessarily a designed effect. If you think about it in the small, if you run in just like a simple DigitalOcean server, let's say, and you've got an Nginx site set up, it's hosting 3 different things. You set up domain names so that three different domain names are all served by this one droplet. And then you set it up so it can serve, you use something like SNI, and then you can serve all of those over SSL. And then maybe you've got some proxy, right? Because, behind that, you might have one static site. You might have a PHP app running that you need to, forward over a socket. You might have something where you're actually forwarding back to an internal network somewhere else, or another host that's connected with their internal networking. There's tons of different use cases. And so that you could use this there, but you wouldn't. You would just rely on the fact that almost all the time, the DNS name, the SNI name, and the host header all match. And it's only in particular configurations that you can actually take advantage of this. And then in particular, the fact that like 3, 4, I don't know, maybe 10 at the most providers dominate these giant CDNs at the edge that actually serve all this content, that's the thing that makes domain fronting actually work at all or have any real place in the world. Because if it's, if it's some small provider, you'll just block them. But if it's Google or Amazon or Microsoft or Cloudflare, you can't block them because your citizens will complain there's too much legitimate content on there. That's why it gets complicated for those big providers, because one, it was never like a service that they were officially providing or really. Now, there has been some talks about it. There has been some, some winks, some backroom nods about like, yes, this is happening. It's not like they didn't know. But in many ways, it was kind of an artifact of the way that their networks and modern networks and architectures have been structured. And it could prevent some problems for their brands because, yes, you can use it for anti-censorship, but there's been multiple accounts of malware using the same thing. Because if you can get your stuff hosted, or you can get a proxy or a cache behind a legitimate domain name that knows how to forward to your content, you can get access to it no matter what. So you could, if you were a malicious user, let's say you could front using like Dropbox's website. If you could make a connection out to Dropbox, that looks pretty normal on a network. iXSystems won't care. There's probably already whitelists or other rules set in place that like, oh yes, this looks like normal traffic, or someone's connecting to Slack, or someone's connecting to Google. But if you can then use that to forward, maybe you're stealing intellectual property, maybe you're connecting to a command and control server to control your botnet, that's where it gets difficult. And I think the risk just for large companies has become too much.
And I could pretty easily see all of these companies making the justification that this is in line with their terms of service of the system, or this is in line with maintaining load and traffic and all of these different things. Like there's a bag over there, just over their shoulder, of like a dozen different justifications they could use, from it fits our terms of service, it's better for traffic management, et cetera, et cetera. And it also happens to line up with current political goals. So it seems like this was always going to happen, but it does have a censorship effect in a way. And so some people like Senator Ron Wyden and Senator Rubio are attempting to raise awareness about this and attempting to get information out of Google and others. So there is some pushback about these changes, but I think it's probably here to stay.
Yeah, I think you're right. I mean, there's just a lot of considerations on the big content provider side where you don't want your brand to be tarnished. There may be legal implications about people, I don't know how much trademarks come into play over certificates, but just using those names at all. And of course, like, especially in the United States with somewhat fickle political winds, one day we can be like, you guys really need to enable this because it can help our agenda overseas, help provide information to people in oppressed or censored countries. Yes, that's great. But can you imagine a world where we talked about this from the other side, where we were like, because of negligent network practices, Amazon and Google allow all of these bad actors and malware to make connections that seem legitimate, and they would be, they'd be harangued. Maybe there would be stock price implications. So it's not really that clear. It's really up to like the community, to the internet at large. Do more good actors use this flaw or specific configuration? Or do more bad people use that? And how much risk are we willing to have? And so if there are big parties, if the government is willing to say like, look, we won't hold you responsible for bad actors abusing this flaw because we recognize it does a public good for the world, okay, maybe then we can get this back. But I can see why large companies just don't want to take that risk.
Yeah, I think that's pretty reasonable, and it really underscores how important the existing remaining tools are and how we need to support them in ways that we can. I think also when you come up with tricks like this or hacks like this that are dependent on large infrastructure like that, you almost have to plan for them to go away eventually. Like, build that into your planning if you can. That would be like the TechSNAP pro tip for censorship tools.
Yeah, have backups and then backups of your backups, because you ain't ever going to know what these big cloud providers are going to do to you.
I like that we now have pro tips for censorship tools here on the show. It's just one of the many services the TechSNAP program can provide. Additional information, and including some real deep dives in the show notes, go to techsnap.systems/376. Let's take a moment and thank the folks that make this show possible, like iXSystems. Go to iXSystems.com/TechSNAP to learn more about iXSystems and support the show. In fact, they got a white paper there you can download. I'm going to make a jingle out of that one day. They got a white paper there you can download, where you can download that white paper and learn more about iXSystems and perhaps encourage the folks around you. Encourage adoption in your organization of iXSystems. You're going to want to build your entire infrastructure around this. If it matters to your business, build it around iX. They know how to create workloads around open source software, and they work closely with hardware providers upstream. That's why they're behind TrueNAS and FreeNAS. Yeah, you know all about FreeNAS. We talk about it all the time. But go check out TrueNAS, which provides unrivaled data integrity protection by using, what else? OpenZFS, which we all know and love, but they also combine it with tons of compatibility. It's both a NAS and a SAN, supporting multiple block and file protocols, which gives you flexibility and choice of application while reducing the number of storage arrays you need. And it's built by iXSystems, so you know it's that white glove process from beginning to end, with full support for all of the great virtualization systems. All the great virtualizers. iXSystems.com/TechSNAP. Nobody builds it like iX, and they're the only ones we recommend. They're also great members of the community. Go check out their blog for great insights to events that they attend. iXSystems.com/TechSNAP. Enterprise features for all sizes of business, with TrueNAS and FreeNAS and custom systems they've built for any solution you need that runs on open source. iXSystems.com/TechSNAP. And a big thank you as well to Ting for keeping this show on the road, techsnap.ting.com. Ting is smarter than unlimited. If you use less, you pay less. And when you go to techsnap.ting.com, you get $25 off a device. Or if you bring a device, and by the way, they have CDMA and GSM networks, then they'll give you $25 in service credits. Now, that'll probably pay for more than your first month because the average Ting bill is just $23 per phone per month. You pay for what you use, a fair price for however much you talk, text, and data you use. And they have nationwide coverage, so Ting's got you covered there. And they have no contracts, no early termination fees, no service agreements, quote, unquote. Nothing weird like that. You're always in control with their fantastic control panel and their excellent customer service, who are a little bit on the maniac side. I don't know how they can be so passionate at their jobs. It starts because Ting hires Android geeks or iPhone geeks, so they're people that are really passionate about phones. They're the guys and gals that fix people's problems in the family and in the social group. That's who Ting hires to do their customer service, and it's brilliant. I remember one time when I was stuck in Montana and I had a MiFi issue, and they stuck on the phone with me for an hour and 45 minutes until my problem was resolved. Even including getting disconnected once. That's why Consumer Reports ranks them as one of the best phone carriers in their survey. And Consumer Reports doesn't endorse products or services. They just tell it like it is. And that's their opinion. And mine too. I've been a customer for more than 4 years now. TechSNAP.ting.com. Go there to learn more and check them out. And after you go to TechSNAP.ting.com, why not wander on over to their blog, where they have a few fiber optic cable networking term breakdowns for you to help explain what it all is, just in case you're trying to get up to speed on what all the different terms with fiber optic networking mean. They've got a handy guide to help you. Start by going to techsnap.ting.com. And the highest of high fives to DigitalOcean, do.co/snap. Thank you to DigitalOcean for sponsoring the TechSNAP program. And thanks to you guys to going to do.co/snap, because you support the show and get a $100 credit where you can kick the tires over on DigitalOcean's crazy, cray-cray fast infrastructure with all enterprise-grade SSDs, 40 gigabit connections coming into the hypervisors. Of course, it's KVM and Linux on the host platform, and then you can deploy free BSD, all free BSD, and nothing but... Oh, what's that? Hold on. Note coming from the back office. Says here they also have tons of great Linux distributions. Oh, like many of the popular Linux distributions you'd expect. Oh, okay. Oh, including one-click deployments of applications. You just click one button and you get the entire thing. Oh, and it turns out they do as well have FreeBSD. They have some of the easiest to use tools I've ever used whenever managing a virtual infrastructure. They call them droplets. I call them gifts from DigitalOcean. You go there, you use that interface, and even if you've never deployed a server before, you'll find it simple and straightforward. But if you've been doing it for years, you'll find it extremely powerful and sophisticated. Plus, they have an easy-to-use, well-documented API on top of that, where you can integrate into your tools or take advantage of tons of open-source tools already built. Monitoring and alerting, cloud firewalls that block the traffic at the network level, data centers all over the world with a 99.99% uptime SLA. Now, my favorite system is just 3 cents an hour, which will get you 4 gigabytes of RAM, 2 CPUs, 80 gigabytes of SSD, 3 terabytes of transfer, and it's 3 cents an hour. But with that $100 credit, I'm going to encourage you to go big. So go to do.co/snap, get the $100 credit, and try out some of their flexible droplet plans. These are a great deal where you can mix and match the resources that you need for your application. Or why not play around with one of their dedicated CPU droplets if you have some CPU-intensive workloads coming up? Check them all out at do.co/snap. And while you're there, if you're trying to wrap your head around Kubernetes, they have a great guide they just put up on networking under the hood for Kubernetes. It's a great breakdown of how the terminology works, how the different parts interact as a whole. And of course, it's in their traditional, well done, easy to follow, great design for these types of guides. Check it all out by going to do.co/snap. And a big thank you to DigitalOcean for sponsoring the TechSNAP program, and a big thanks to all of you who visit our sponsors' URLs.
Thanks for heading to techsnap.systems/contact to send us all of your fabulous feedback, war stories, horror stories, or top tips on your favorite technology tools. One tool that got a ton of feedback this week is Duplicati. In particular, Matthias writes to us with his review of why he likes it just so much. He writes, I was just listening to an episode on backups. A solution I really like is Duplicati. Duplicati is a tool that runs on localhost as a web app, and it acts as a front end that you can bring in an arbitrary backend. It supports everything from local drives to S3. It runs on Windows, Mac, and Linux, of course. And the software lets you configure different backup schedules using different retention policies and backends. The setup I like is to have a dedicated drive for local backups and then also use DigitalOcean spaces for offsite backups. Now, of course, there are some downsides. In particular, it looks like to get it running on a headless server involves a little bit of, as he says, tomfoolery, and you may need to use Docker to help facilitate things. It is a .NET/Mono app, but it's actively developed. They've had a number of releases. You can go check it out more over at duplicati.com, or of course, go check out our show notes. Something else Matthias really likes is that you can integrate with so many different services, and an important factor that he highlights here is that you should consider which services, when you have the choice of things like S3 or DigitalOcean Spaces or Backblaze or 1,000 other options, local FTP. Some services allow you to get a physical device shipped to you when you need to do a restore. So if you don't want to take, 3 weeks to go download all of your data over whatever slow cable connection that you might have, some services like Backblaze will actually let you pay more, or, if you're on the right plan, you can get a physical drive shipped to you in the case that everything goes wrong and you just really need that data. So good tip, Matthias, and thanks for pointing out Duplicati. That's one I hadn't heard of. It is a little hard to say, and there are so many bad names in this space and just name collisions all over the place. But this definitely looks like one to check out. In particular, I like that it runs on, Windows, Mac, Linux, and because of the web app functionality, it might be a good tool for users who aren't particularly technical, but can be trained enough to go to a web app, click some settings and set things up, and then get their system integrated into whatever backup schedule that you've got for others.
Yeah, this has been on my radar on and off over the last couple of years because I keep hearing it brought up by the audience, and then we definitely got a lot of it in this last week. So I thought, okay, I'm going to go take a look at it, and I was really impressed. I agree with what you just said there, is the web UI is straightforward and easy enough that you could, as an administrator, set it up and then hand it off to somebody who's more of a support role to manage the backups and check to make sure things worked and restore files. That could all be done by somebody who's not necessarily the primary sysadmin. And I love that about a system, because if you're deploying something for an enterprise or even a small office and business, it's nice if you can break it up like that. So yeah, your analysis is correct based on what I saw, and I am very, very tempted to give it a go. It looked really great, and even if it was just initially in a Docker container or running it maybe in a VM on our FreeNAS here, I think it could be pretty useful. So I really appreciate the audience telling us about that. We also got some feedback from Ben, who just wanted to make sure we point out some of the basics for backup. Make sure at least one full copy is offsite to protect in the case of a fire or theft, and make sure that one copy, at least relatively recent, perhaps a weekly snapshot, is kept completely on cold storage, air-gapped from everything, and ideally not connected to a power-on system. In the event of a complete compromise, then you know you're safe because it would be completely out from everything else. Now, we used to take a very regimented approach at several different places I worked at rotating physical media, where somebody would actually get in their car and we had a special locked case, and we would carry tapes from one secured facility to another secured facility that was at the other end of town, and that was what the company considered offsite and good enough. You could argue that that's not enough, and that perhaps they could have just invested in services that take care of that, but that was something they were very aware of, and they checked it off as one of their due diligence for their data, and there is actually some legitimacy to that idea, is getting your data offsite, getting it disconnected from your primary systems. A weekly snapshot is great. All of that is, I think, pretty key. And we got a great email that came into the show that talked about the challenges when you're dealing with gigs and gigs and gigs of encrypted backups as well. So we're still collecting your ideas and your feedback on best backup practices, systems that have worked well for you, things that people should be thinking about when they're setting up a backup system for the first time. Keep all of that coming in. TechSNAP.system/contact.
Well, now that we've got our backups in order, that brings us to the end of this week's installment of the TechSNAP program.
If you've recently found the TechSNAP program useful or informational and have time to leave us a review on one of your favorite podcast destinations, you know what those might be. They always help out discovery, helps other people find it because it moves us up in the search algorithms and things like that. So if you're an Overcast, a star always helps, or if you're on Apple Podcasts, a review always helps. Anywhere where maybe you could help spread the word, we appreciate that effort, and we'd love for you to get our show every single week, and you can get our subscription links at techsnap.systems/subscribe.
If you just can't wait until next week's episode, you can find more of us on the Twitterverse. He's at ChrisLAS, and I'm at Wes Payne. Thank you so much for joining us.
And we will see you next week.